Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Mauve by Lithium Ion, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. Each pink Renban line contains a set of non-repeating consecutive digits in any order. So as an example, you could have something like, say, 2, 4, and 3 here, and that would be valid because these digits form a set of non-repeating consecutive digits, 2, 3, and 4. What you could not have is something like, say, 2, 5, and 3, because 2, 3, and 5 does not form a set of consecutive digits. So that's an example of how Renban lines work. Also, we have digits along an arrow summed to the digit in the corresponding circle. So, for example, if this were, say, 2 and 6, this would have to be 8, because the digits along the arrow must sum up to the digit that is in the circle. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay. I'm not really sure. So these digits, okay. What digit can this be? This digit is a sum of 3 unique digits, so it has to be guaranteed 6, 7, 8, or 9. Therefore, this Renban cannot contain all of the digits from 6 through 9. What sets then can it be? 1 through 6 does work. 2 does it though? The problem with that, I guess it does. Okay, so 1 through 6 works. That would force these to be 7, 8, and 9. Essentially, that would force this to be 9. These are 7, 8, and these have to be consecutive with it, so it'd be 5 and 6. So that does work. This set of Renban has the same problem, right? You cannot contain all the digits from 6 through 9. So you can never have a 9 here on this Renban, because if you did, it would have to be a 4-length Renban of 6, 7, 8, 9. In addition, this row 1, you can never have a 9 here, because that would force the Renban to be 4, 5, 6, 7, 8, 9. And that would eliminate all possibilities for this cell. So, where can the 9 be in row 1? It can't be here, because again, this if it's here, it would force this to be a 6, 7, 8, 9 Renban, and that would eliminate all possibilities for the cell. And same with this. If it's here, it would have to have a 4 through 9 Renban, which would eliminate all possibilities for this cell. So the only place in row 1 where you can have a 9 is this cell. Okay. Now this is a sum of either 1, 2, 6, 1, 3, 5, or 2, 3, 4. If you have 1, 2, 6, can you ever have a 4-length Renban in the same box? And I think the answer to that is no. 1, 2, 6 divides up the consecutive sets into 3, 4, 5, and 7, 8, none of which are 4 in length. So that does not work. 1, 3, 5 has a similar problem. You have a set of 2, a 4, and then 6, 7, 8 by itself, unfortunately, is not 4 in length. So this must be 2, 3, 4 here, which forces this to be a 5, 6, 7, 8 Renban. That leaves this as 1 here. And this must contain 2 and 3. Actually, it has to have 1 also. So there's no other place for 1 to be in row 1. It has to be on this Renban, so it's a 1 through 6 Renban. which means this can't be 5 or 6. It's 7, 8 as a pair. Therefore, this is 5 and 6 here. This 4-length renband does not have access to 5 and does not have access to 6, so it must be 1 through 4 here. So then we have 1 through 4 here. That leaves the remaining digits in this column as 7, 8, and 9. Okay, 2, 3, and 4 is consecutive with 1 through 5. One of these has to be 9 on this, in this upper central box. 9 can only be on a renband with 7 and 8. So one of these is 7, 8, and 9. That leaves this to be 1, 2, 3, or 2, 3, or 4, 5, 6. Obviously, this can't be 1. Cannot be 4, 5, 6 either, so this has to be a 7, 8, 9 triplet. Because in this upper central box, we have to have a 9 on a renband. 9 can only be with 7, 8. So one of these is 7, 8, and 9. Actually, that's not necessarily true. You could potentially have 2, 3, 4 or 3, 4, 5 on one of these, in one of these sets. One of them definitely has to be 7, 8, and 9, though. One of these sets has to have a 9 in row 2, so it must be 7, 8, and 9 to be with it. That means the other one, it can't have a 1. It cannot be 2, 3, 4. You also can't have 5 and 6 together. So that means one of these is 7, 8, 9, and the other one has to be 3, 4, and 5. So this cannot be... Oh, this digit has to be 6 through 9 because it's a sum of 3 unique digits. Same with this. This is 6 through 9 also. It's a sum of 3 unique digits. So these have to be a combination of 7, 8, 9, and 3, 4, 5. So that leaves this as 2 and this as 6. So that leaves us as 5, and this can't be 2 here. So it's 3, 4. We have 3, 4, 5, and 7, 8, 9 here. So if this is 3, 4, 5, this becomes the 3-length renband here. It could be 1, 2, 3, 3, 4, 1, 2, 3, 2, 3, 4, 3, 4, 5, or 4, 5, 6, but it has to have one digit from either 3 or 4. So it cannot be here. So this must then be a 7, 8, 9, which leaves this as 7, 8, 9 here. That eliminates 7, 8, 9 in the rest of the box. So this can't be 7, 8, 9. It's 6, which is a sum of the digits from 1 through 3. These cannot be 1 through 3. It must be 4, 5 as a pair at minimum to add up to 9, which means this does have to be 9. Remaining digits in row 3 are 1 and 2, which eliminates 1, 2, and 6 in the rest of the box. This cannot be 3 because of the 1, 2, 3 triplet here. This can't be 4, 5 because of the 4, 5 pair in the column. So then this becomes 3. There's no 3 here. 9 eliminates 9 here. This cannot be 3, 4, or 5 here. So this is 1, 2, and 6. Which makes this a 3, 4, 5 triplet here. Remaining digits in this right central box are 6 through 9. This can't be 9 because of 9 in the column. And we have a 6, 7, 8, 9 quadruplet in column 7, which eliminates 6, 7, 8, 9 in the rest of the column. So this is 1 through 5. Obviously, it can't be 1 or 2 here. So this has to be 3 or 4. We are guaranteed 3 has to be one of these. We are guaranteed 6 has to be one of these, which means this can't be 6. It's 7 or 8. To add up to 5 at most, these must be 1 through 4, which means we have a 1, 2, 3, 4, 5 quintuplet. This can't be 3 here. We have a 1, 2, 3, well, we have a 1, 2, 3, 4, 5 quintuplet in this lower right-hand box. So the rest of this can't be 6. 6 has to be here. So this must be a 7, 8 pair left here. That means this can't be 7 or 8. It's 9. This can't be 9. It's 7 or 8. If we have 3, you cannot have 4 here because it would require 1 and 3 to be here. So if this is 3, this is 1 and 2, adding up to 3. If this is 5, this would have to be 1 and 4. But if we had 1 and 2 here, well, this can't be 1 or 2 because of the 1, 2, 3 triplet in the column. So this can't be 1 or 2. It must be 4, which makes this 5, which makes that 4. So 1 and 4 add up to 5 here. So then this can't be 1, 4, or 5. It becomes a 2, 3 pair here. This 2, 3 is a 3-length rem band without a 4. So it must be 1, 2, and 3 here. This 2, 3 pair. This 1 eliminates 1 here. So that's 2 and 1. This 6, 7, or 8. So we're guaranteed a 1 in one of these two cells here to force this Ren band to work. Because we don't have access to a 4 available. And to add up to 6, 7, or 8, you are required to have one digit be 1, right? To add up to 6 is 1, 2, 3. To add up to 7 is 1, 2, 4. To add up to 8 is 1, 2, 5 or 1, 3, 4, but you have to have a 1. Well, 1 can't be here because of 1 in this Ren band, so 1 has to be here, which means this cannot be 1 here. And could be 1, 2, 3, could be 1, 2, 4, could be 1, 3, 4. But we have a 2, 3, 4 triplet in row 7, which eliminates 2, 3, 4 in the rest of the row. So this is 6, 7, or 8 here. Remaining digits of row 9, we have 5, 7, 8, 9. Okay. Well, we have a 5, 7, 8, 9 quadruplet in this lower left-hand box, which eliminates 5, 7, 8, 9 in the rest of the box. This can't be 7 or 8, it's 6. So this can't be 6. So this has to be either 1, 2, 4 adding up to 7 or 1, 3, 4 adding up to 7. So we're guaranteed a 4 here, which means this cannot be 4 here. This has to have a 4 here, and it has to be 2 and 3 added up with it. So it can't, 2 and 4 add up to 6, which that can't be. So it must be 3 and 4 adding up to 7. So this is 7, which makes this not 7. This is 8 and 7 there. That eliminates 7 and 8 here, so that's 9. That means 7 and 9 cannot be here. It's a 5, 8 pair, which eliminates 5 and 8 in the rest of the row. So this can't be 5, 8, or 9. It's 7. That eliminates 7 here. 1, it'd only be consecutive with 2, so this can't be 1. Okay. We have remaining digits in column 3. Oh, this is 3, 4 as a pair, which eliminates 3 here, so that's 2. This cannot be 1, 2, 4 now. So that's 1, 3, 4 adding up to 8. So this is 8, which makes this 7, which makes that 8. This 3, 4 pair eliminates 3, 4 in the rest of the box, so this can't be 3. That makes this 1 and 2, which eliminates 1 and 2 in the rest of the row. Therefore, this is not 2, it's 3, which makes that 2. Okay, these can no longer be 2 here. 2, if we try to have anything here, does not work because 2 is only consecutive with 1 or 3, and we already have a 1, 3, 4 triplet in the box. So 2 can't be here, 2 can't be here because of 2 in the column. 2 has to be here. which means this can't be 2. 9 cannot be here. Because of 9 in the column, 9 has to be one of these two, which would be then consecutive only with 8. So 8 has to be here, which means this can't be 8. It's 5, which makes that 8. So the last remaining digit here has to be a 5. So this must be 5 or 9. 5 is only consecutive with 4 or 6, and 4 is eliminated by the 1, 3, 4 triplet in the box. So this must be 6 and 8, which leaves this as a 7. That means this can't be 7 here. To add up to 7, it's either 1, 6, or 3, 4. Well, we have a 1, 3, 4, 6 quadruplet now in row 6, which eliminates 1, 3, 4, 6 in the rest of the rows. So this can't be 4. It's 5, which makes that 4. Also, this can't be 6, so it's 8 or 9. Which means the remaining digits have to be 8 or 9 here. Where is the 6? This 8 eliminates 8 here, so that's 9, which makes this 8. This can't be 8 or 9 here, so that's 7. Therefore, where is the 6 in row 6? It has to be on this arrow, so it's 1 and 6 adding up to 7, which means this can't be 1. This is 3. This can't be 1 or 3. It must be 4. So no 4s here. No 3s here. These can't. This 8 eliminates 8 here, so that's 7, which makes this 8, which makes that 7. So these cannot be 7 or 8 here. So this is guaranteed to be 6 or 9. This is also guaranteed to be 6 or 9. If it's... there's a lot of potential varieties here. If this is 6, it cannot include a 1 because this is a 1-6 pair here. So if it's 6, it's 2, 4. Otherwise, if it's 9, it cannot be 2, 7, cannot be 1, 8, cannot be 3, 6 because of the 1-6 pair here. So it would have to be 4, 5. So we're guaranteed a 4 here. So this is either 4 with 2 or 5 adding up to 6 or 9. So that means this can't be 4 here. Where is the 8 in row 4? Cannot be here, cannot be on the arrow, cannot be on the Renban line, so it has to be here. So this is 8, which makes this 9 to be consecutive with it. That's 5 and 6. That means this has to be 6, that's 9, and this must be 2 and 4, adding up to 6. That eliminates 2 here, because of the 2, 4 pair, so it's 1, that's 2. 1 eliminates 1 here, so it's 3 and 1. This can't be 2 or 3, so it's 5, which is only consecutive with 4 out of 3 or 4. So that's 4, which makes us 3. That makes us 4 and 3 there. 5 eliminates 5 here. We have a guaranteed 2 in one of these cells here, and a guaranteed 2 in one of those cells here. Where is the 2 in column 4? It must be here. So that's 2, which eliminates 2 here and 2 here. And the rest will probably just do normal Sudoku. Remaining digits in row 5, we have 3, 7, 8. Okay, this can't be 7 or 8 because of 7, 8 in the column, so that makes this 3. There's no 3 here, no 3 here. 7 eliminates 7 here, so this must be 8 and 7. 8 eliminates 8 here, so it's 9 and 8. 3 eliminates again 3 here. Remaining digits we have a 1-6 pair in column 5, which eliminates 1 and 6 in the rest of the column. This can't be 1, so that's 2 and 1. 2 eliminates 2 here, so it's 4 and 2. 1 eliminates 1 here, so it's 6 and 1, which eliminates 1 here, so it's 6 and 1. 4 eliminates 4 here, so it's 3 and 4. That eliminates 4 here, so it's 3. This can't be 3 or 4, it's 5, which makes this 4, which leaves these digits as 5, 9, and 6. Congratulations, you solved the puzzle, which is named after the color mauve, which is similar to a blend of pink and gray. That is the two colors used in this grid. Okay. I didn't know it was a combination of pink and gray. Interesting. Yeah, I mean, seemed pretty straightforward. I did like the logic behind the Ren bands. That was actually very interesting. And then that combined with the arrows did make for some interesting interactions. Either way, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.